Hey folks, happy Thursday. Good to see you. Before we get into today's lesson, as far as I can tell, it looks like the test went moderately okay. I heard from a couple of you with an issue here, an issue there, in terms of, it's learning, not loading an image or something like that. But I didn't hear a ton, so that feels like it went moderately successful in terms of taking it, I guess. But anyway, so if you were a person that maybe had something go on yesterday or an issue yesterday that I still have not heard about, please let me know, just so I have kind of a better gauge of how that went for all of you. My plan is to go through that and maybe have a score for you ready for tomorrow. Tomorrow, we're doing nothing. Okay, it's going to be a free and open Friday for AP Chemistry, which is good. But at the same time, please be aware that if you're a person who's missing something, okay. If you have one of those assignments still from first unit that you haven't turned in, try to do that tomorrow. If you have one of the 2 lab Fridays from the previous 2 weeks that you haven't accomplished yet, go back and do one of those and try to catch up, okay? So I'm not giving you anything new tomorrow, but if you're all caught up, awesome, you're good to go. But if you're somebody who just has missed something here or there along the way, please, use tomorrow to maybe take care of that and catch back up, okay? Today, we're going to do topic 2.1, so we are going to jump into unit 2. I am not going to do a ton today. My energy level is like completely in the dumpster, as I'm sure maybe yours are as well. So I really don't want to get too far into this, but I do want to give you a little bit of something to get started with unit 2. But yeah, I'm not quite feeling it today, which, we're all human. and I'm not the type of personality to keep smacking my head against a wall when it's not feeling the best. So we'll slow it down a little bit. We'll accomplish some things. We'll call it a day much earlier than we did on Tuesday with the review, because the review day was rather intense. So let's take it a little easier today. All right. So topic 2.1. We are going to be talking about the types of chemical bonds today, which you are, again, moderately familiar with. We are going to talk about some new things today that we didn't talk about last year in chemistry. But there are certainly things in today's lesson that you have heard of before and you should be able to identify. So our objective, explain the relationship between the type of bonding and the properties of the elements participating in the bond. All right, try this. In your own words, describe what an ionic bond is from last year. In your own words, describe what a covalent bond is from last year, if you remember. I'm not asking for a perfect definition, but take 30 seconds and jot something down really quickly from your memory. All right, somebody want to unmute? What do we got for an ionic bond? What do you remember? Or how would you describe an ionic bond from last year? Does anyone want to try to describe an ionic bond from last year? Anyone at all? All right, I'm caving. You guys win. Congratulations. You've broken my spirit on a Thursday. So an ionic bond is typically the way you described it last year was a bond between a metal and a non-metal, right? You were oftentimes asked early in the year last year to identify, hey, is that ionic or is that covalent? And the way you did that is you were looking for a metal and a non-metal, or you were looking for a polyatomic ion, if you remember polyatomic ions from last year, okay? So I'm going to give you a little better definition. An ionic bond occurs when there is a transfer of electrons, or one electron. I'll use E- as my symbol for electron again. So the transfer of electron from metals to nonmetals. all right? If you remember, your positively charged ions were always metals. Your negatively charged ions were always nonmetals. So an ionic bond happens when an electron leaves a metal and is taken in by a nonmetal, all right? Then as a result of that, as that electron transfers, you have a positively charged cation, a negatively charged anion, and the positive and the negative charge are attracted to one another. And that's what forms what we call an ionic bond, okay? I'm going to calibrate my board really quick because that was just slightly off. And I certainly don't need any help writing poorly. All right, for covalent bonds, last year you typically described this as non-metal, all right? But I'm sure you know this as well, and this is what I'll use today. This is when electrons are shared between atoms. Okay, so this should be nothing new. I hope it's nothing new. But ionic bonds typically occur when electrons are being transferred between metals to nonmetals, and covalent bonds occur when electrons are shared between atoms, oftentimes between two nonmetal elements. So I have some compounds from last year. Classify what types of bonds, not the overall compound, okay, but what types of bonds are in all of these examples. Certainly, it's been a year since you've really talked about this stuff in depth. So take a shot, take a look at these. If you have a periodic table nearby, that probably would be helpful. And maybe even last year's periodic table would be more helpful. But I'm asking you to see if you can correctly identify the types of bonds in these 6 examples as ionic, covalent, neither, or both, okay? I'll give you a minute or two to go through these 6 and jot an answer down for each. Then we'll come back and I'll explain what the correct answers are and why. Go for it. Again, please make sure you've also typed here in the chat. Looks like everyone has, or almost everyone has. All right. So the first one, sodium chloride, NaCl. Sodium is a metal, chloride's a nonmetal, or chlorine's a nonmetal, okay? This is your classic example of an ionic compound, and that's absolutely true. Okay? Nothing new, nothing exciting there. The next one, carbon dioxide, CO2. This is nonmetal. That's nonmetal. Carbon's nonmetal, oxygen's nonmetal, 2 nonmetal atoms. This is an example of covalent. Okay. Now, the next one is called the ammonium acetate from last year. Ammonium, this first chunk, NH4, has a 1+ charge. This is a polyatomic ion. This is the only positively charged polyatomic ion that we had on last year's periodic table on the back of that. Okay. This, the other chunk, the C2H3O2, that is acetate with a 1- charge. It's also a polyatomic ion from last year. Okay. So ammonium acetate is the positively charged NH4 1+, the negatively charged C2H3O2 1-, and the attractive force between them is known as an ionic bond. But we also have covalent bonds in this molecule as well. This is an example of both types of bonding being present. Let me explain again and a little further, okay? In my NH4, I have a nonmetal, I have a nonmetal. Ammonium has two nonmetal elements bonded together. The types of bonds that occur between nonmetals are covalent. However, that makes up a polyatomic ion. So within this polyatomic ion, there are covalent bonds. Within acetate, the other polyatomic ion, there are covalent bonds. But when I bring these two polyatomic ions together to make the full molecule of ammonium acetate, the bond between these two polyatomic ions is ionic. There's been a transfer of electrons. This is one positive, this is one negative, and they're attracted to one another. Okay, so this is an example of both types of bonding in this third example. I2, it's iodine bonded to itself. Iodine is a nonmetal, so if the first iodine is a nonmetal, the second one is also a nonmetal. So it's a nonmetal, nonmetal, this is covalent. And then I have magnesium chloride. Magnesium is a metal, chlorine is a nonmetal, this is ionic. And then I have H2SO4. This is actually sulfuric acid from last year, if you remember that. And this one's much tougher to see because if you look at this, I have a nonmetal, and a nonmetal. Hydrogen, sulfur, and oxygen, the three elements in that compound, are all nonmetals. So you want to kind of probably lean towards covalent, and that's partially true. There are covalent bonds. But remember, SO4 is a polyatomic ion. SO4 has a 2- charge. It's called sulfate. So there's covalent bonds between the sulfur and the oxygen atoms in the sulfate. But hydrogen can have a 1 positive charge as well. So I have 1 positively charged hydrogen ions, and I have a 2- charge. This ends up being both as well. That is by far, I think, the most difficult of these 6, but we do have both types of bonding in that molecule. Now, the energy, this is the bottom sentence, obviously, the energy that exists in an ionic bond is the result of the attractive force between positive ions and negative ions. Last unit, in Unit 1, we were talking about Coulomb's law just a little bit, and that did show up on your review sheet as well. So Coulomb's law it's a mathematical formula, but it's a law that allows us to describe how strong the attractive force is between two particles that have a charge, okay? So when we talk about ionic bonds, what I'm really talking about is I have a positively charged ion or polyatomic ion, just depends, and I have a negatively charged ion or polyatomic ion. I've got a positive chunk, cation, I've got a negative chunk, anion, and there's an attraction between them. Coulomb's law is actually going to help us describe the strength of an ionic bond as well in this unit, okay? So last unit was all about like protons and electrons. We used Coulomb's law loosely, just in general, to kind of describe ionization energy, right? How strongly outer electrons or valence electrons were attracted to the nucleus where the protons are. So we'll kind of, the theme of these attractive forces is going to be a big part of this unit too. All right, so speaking of which, got ahead of myself just a smidge, but Coulomb's law says that the energy between two charged particles depends on the magnitude of the charges. And when I say magnitude, I mean like, you can think of it as like the numerical value, right? And if I have 1+, 2+ is a larger magnitude than 1+. Just like 2- is a larger magnitude than 1-, okay? So as you get larger charges, either positive or negative, the magnitude has increased. And a larger magnitude of charge leads to a stronger attractive force between the atoms, between the proton and the electron, whatever you're looking at, okay? The second part of Coulomb's law is all about distance. How far apart are the particles? The closer they are together, the stronger that attractive force is. So this is an equation. We'll never actually use it. The Q's, Q1, Q2, that's talking about the charge. Q1 is the charge of the first particle. If it's an electron, for example, it'd be -1. Q2 is the charge of the second particle. If it's a proton, it'd be +1. R squared on the bottom is related to distance, okay? So charge goes up. If the magnitude of charge increases, the attractive force increases. If the distance between the particles decreases, in other words, if they get closer together, the attractive force increases. So I'm kind of answering the questions down below, but as the charge's magnitude increases, the attractive force increases. As the distance between the charged particles increases, the attractive force decreases. Okay, so again, more distance equals weaker force, less distance equals stronger force. As the attractive force increases, that means it is blanker to break the ionic bond. So using the example of ionic bonding, if there's a stronger attractive force between my cation and my anion, it must be harder to break that bond, right? Greater attractive force means it takes more energy to break that. Of course, don't forget that like charges repel one another and opposite charges are attracted to one another, or opposite charges attract. Okay. And I am almost done, by the way. I'm not going to go too far, like I said today. We'll talk about electronegativity just a little bit, and then we'll call it. So, classifying chemical bonds simply as ionic or covalent does not tell the whole story. So, this is where I'm kind of changing your viewpoint of chemistry a little bit again, all right? So it's really nice and easy, and we did this in regular chemistry last year. It's a much easier thing to do to just view things as very black and white, meaning that is ionic, that is covalent, right? And it's essentially two distinct categories, and it's either one or it's the other. That feels nice and happy. But in reality, that's not what it is in chemistry, all right? In reality, what we have is that bonding, or when two atoms are attracted to one another, either through transferring electrons or sharing electrons, it's a little more in-depth and a little more complicated than just to call it either ionic or covalent. It's a spectrum, okay? There is a spectrum of bonding in chemistry. So we need something to help us identify what type of bond we might actually have. And that's going to lead us to something called electronegativity. All right. So electronegativity, this was on topic 1.7, but I skipped it and I said, hey, we're going to talk about this later. Well, later is now here. So electronegativity can be defined as this. It is how strongly an atom attracts shared electrons toward itself. Okay. Electronegativity is a property that describes how strongly an atom attracts shared electrons towards itself. And when I say itself, I really mean its nucleus, okay? Because the nucleus is where the positive protons are. So hold on. Poor word choice, I apologize. okay, towards its nucleus. So some atoms have a very high value of electronegativity. What that means is that atom attracts shared electrons, like electrons in a chemical bond, very strongly towards its nucleus. Other atoms have a very low electronegativity. That's trying to imply that the nucleus of that atom doesn't pull or doesn't have as high of an attractive force towards the shared electrons in a chemical bond. Let me give you a little more context, okay? So each element has a numerical value of electronegativity, all right? What is the general trend for electronegativity? Let me give you this, and then I'm going to call it. So, in general, as you go from left to right across a row, electronegativity goes up. In other words, the element fluorine has a higher electronegativity than the element beryllium. All right. Up and down a column, electronegativity increases as you go up. Okay. The 5 most electronegative elements on the periodic table are right here. Is that 6? That's 5. Okay. Just making sure I can outline things. Fluorine, oxygen, nitrogen, chlorine, and bromine. These are the 5 most electronegative elements. And there's a stupid mnemonic to remember this. And that's phone, Chloe, bro. Okay, F-O-N for fluorine, oxygen, nitrogen, Cl for Chloe, bro, Br for bromine. Okay, so phone, Chloe, bro. It's super lame, and I'll make many lame jokes about it later. But it works. These are the 5 most electronegative elements. And again, let me just recap what electronegativity is and why this is important moving forward. Okay, electronegativity is a numerical value that's trying to describe how strongly an atom attracts these shared electrons in a chemical bond towards its nucleus. These 5 elements, fluorine, oxygen, nitrogen, chlorine, and bromine, have very high values of electronegativity, meaning they pull the shared electrons in a chemical bond close towards their nucleus, or towards their nuclei. Okay? And as a result, looking at electronegativity and analyzing what the electronegativity is of one element and another element that have a chemical bond between them, we can analyze whether that chemical bond is more covalent in nature or more ionic. All right? I'm going to leave it there. I'm going to call it a day. I have no new work for you tomorrow. But again, if you are a person who is missing something from the first unit, any of the first 3 homework assignments, either of the 2 Friday lab assignments, please work on that tomorrow and get that finished, okay? I have no homework for you for over the weekend. You got nothing tomorrow. If you're caught up, enjoy your 3-day vacation from AP Chemistry. That's all I got. Have a great day, guys. If you haven't typed here, please type here in the chat. Other than that, we shall catch you on Monday. Bye, guys.
Mr. Barazin.
Yes.